Hello dear students of class 1, medical, non-medical, respected teachers and dear friends. In this video, I am going to discuss about Mayer's relation between molar specific heats at constant pressure and constant volume. So, to derive expression for Cp and Cv, consider 1 mole of an ideal gas. Then by first law of thermodynamics, we have dq is equal to du plus dw, where dq is known as the amount of heat added or subtracted. Du is the increase or decrease in internal energy of the system. dw is equal to amount of work done by the system or upon the system. And this dw can also be written as pdv. So by first law we have dq is equal to du plus pdv. Now, when pressure is kept constant at constant pressure, dq by dt is equal to du by dt equal to pdv by dt at constant pressure. When pressure is kept constant, this dq by dt at constant pressure is given by Cp, molar specific heat at constant pressure, and therefore Cp is equal to Cv plus pdv upon dt. Because this du by dt is nothing but dq by dt at constant volume is equal to Cv. So by definition, when volume is kept constant, this dv is 0, there is no change in volume. Therefore, dq by dt at constant volume will be equal to du by dt. So by definition, molar specific heat at constant volume is defined as the rate of change of internal energy with temperature. So Cv is equal to du by dt. Therefore, so we have Cp is equal to Cv plus pdv by dt. So this is equation number 1 say. Now, for 1 mole of an ideal gas, we have Pv is equal to RT or pdv is equal to rdt. So therefore, from equation 1, this equation 1, substitute the value of pdv is equal to rdt. So we have Cp is equal to Cv plus rdt upon dt. dt cancels. We have Cp minus Cv is equal to R. So this gives Mayer's relation in units of work. Mayer's relation in units of work. So if we divide R by J, so this gives Cp minus Cv is equal to R upon J. So this gives Mayer's relation in units of heat. So when Cp and Cv are measured in calories, this gas constant value is R is equal to 8.3 joule, whereas R upon J will be approximately 2 calories because J is equal to 4.2 joule and is called J is called Joule's mechanical equivalent of heat. So which is required Mayer's relation. Cp minus Cv is equal to R upon J in units of heat and Cp minus Cv is equal to R in units of work. And from this equation we also see that as R is always greater than 0, so therefore Cp minus Cv is greater than 0, that is positive, or Cp is greater than Cv. It is molar specific heat at constant pressure is always greater than molar specific heat at constant volume. So Cp is always greater than Cv. So this you can explain why Cp is greater than Cv. In other words, when gas is heated at constant volume, amount of work done is 0. So amount of heat supplied to the system is used only to increase the internal energy of the system because dV is 0, dW is 0. But when gas is heated at a constant pressure, amount of heat supplied is used in two ways. One is to increase the internal energy of the system, and number two, to do work against external pressure. So that's why when heat supplied is more when gas is heated at constant pressure than at constant volume. That's why Cp is always greater than Cv for the same change. This is all about Mayer's relation. So we can derive Mayer's relation in a simple way using first law of thermodynamics. Till then, stay tuned. Good luck. Be happy. All the best.